It's always a good idea to organize the information into the table or write down what we have. So I created this table with the information that we're giving. We will consider the number of successes would be the cars with rare license plates only. For Connecticut, this will be RX. For Connecticut, the number of cars with rare license plate only is 239. Let's write down X is 239. The total number is X1 for the first population, and N1, the first population, would be Connecticut. This would be population 1. New York will be population 2. The total number is 2049. Then X2 is the second population. The successes, which are the cars with rare license plate only in New York, is 9. And the total number, and sub 2, is 550. Let's apply the steps. The first step is to identify the claim. Well, our claim is that Connecticut and New York have the same proportion of cars with rare license plates only. Population 1 is the cars in the Connecticut, and population 2 are the cars in New York. So our claim is that P1 is equal, the proportion is the same. The opposite of this claim would be that P1 is not equal to P2. Step 3, identify the null and alternative hypothesis. The null hypothesis will be our original claim because it has the equal sign, P1 equal to P2. And the alternative hypothesis in this case will be the opposite claim, P1 is not equal to P2. Remember the sign of the alternative hypothesis because that's what we will use in the calculator. Step 4, significance level. It was specified as alpha 0.05. Step 5 is to calculate the test statistic. We're going to use technology. We will look how to calculate how to find the p-value and the test statistic on the graphing calculator and on the StatCrunch. On the graphing calculator, go to Stat, Test, down to proportion, Z-test, click Enter, and enter the values of X1, 239, N sub 1, 2049, X sub 2, and N sub 2. After we enter all the values, make sure that you enter the right sign for the P1. It's our alternative hypothesis. In this case, it's not equal to. Go down, click Calculate, and we'll find our test statistic is Z equals 7.107, which is rounded to 2 decimals, will be written as 7.11, and our p-value is 1.19. Don't rush to write it down. If you write 1.19, it will be greater than 1. But remember, p is between 0 and 1. P cannot be greater than 1. Probability cannot be greater than 100%. Wait, there is e to the negative 12. That means 1 times 1.19 times 10 to the negative 12 power. That means that we need to move this decimal 12 times to the left. Can you imagine what a tiny value we will get here? P-value is equal 0.000. We can always almost write it as a 0. it's not exactly 0. There is still some tiny probability, but it's so close to 0 that we can write it as 0.000. If we use the table A2, you will get 0.0001. The technology will give you more precise value. Before we proceed to the next step of making decision, let's think about it. We have the test statistic that is equal to 7.11. The test is two-tailed test. Therefore, our p-value is going to be in two tails. But even though we multiply 0.0001 into 2, it will still make only 0.0002, which is much less than our alpha of 0.05. Plus the test statistic, z equals 7.11, will tell us that it's located way on the right side. So the p-value, the probability that is left here, is going to be close to 0. Therefore, it's in the critical region. If the p-value is less than the critical region, then we reject the null hypothesis. We can use the help of the table to word the final conclusion in the non-technical terms. Our original claim does include equality. So we are right here in these two categories. Original claim includes equality, and we reject the null hypothesis. Therefore, we can say there is sufficient evidence to warrant the rejection of the claim, and we restate the claim. And our conclusion is that there is sufficient evidence to warrant rejection of the claim that P1 proportion 1 is equal to P2. That means there is sufficient evidence to conclude that Connecticut and New York have different proportions of cars with rare license plates only. It's reasonable to assume that the enforcement of the license plates laws is much stricter in New York than in Connecticut, because in New York we had only 9 cars with a rare license plate only, as opposed to 239 in Connecticut, and that's why Connecticut car owners are less likely to install the front license plate. If you use StatCrunch, log into StatCrunch, go to Stat, Proportion Stats, to Sample with Summary, and enter the number of successes for both populations and the total numbers for the samples. After you enter all the values for both samples, go to Hypothesis Test for P1 minus P2. Null hypothesis is that P1 minus P2, that the difference of the two proportions is equal to 0. Alternative hypothesis, that the proportion is not equal to 0. Make sure to change, if needed, the sign of the alternative hypothesis. Go to Compute. As you can see, we got the same numbers in the StatCrunch. Our z statistic is 7.11 and the p-value is 0.0001. So we make the same conclusion. To test the hypothesis using critical value method, we'll need to find the critical value. Let's draw the diagram. Since our alpha is 0.05 and the test is two-tailed, because remember alternative hypothesis is not equal to 0, our alpha is divided into two tails. Each tail will have 0.025, the area. We can use the A2 table or the graphing calculator to find the z-score that separates the critical region from non-critical region. the critical values, the z-score that corresponds to 0.025 to the right of the test statistic, to the right of the z-score is 1.96, and on the other side, negative 1.96. The z-score that we got from the calculation is equal to 7.11. The z-score is located way on the right in the critical region. Since the z-score is, the test statistic is in the critical region and it's greater than the critical value, we conclude that we reject the null hypothesis and write the conclusion the same way we wrote it before.